Okay, I got the function, and let me write this down for you. Y equals a function of x, and that's x minus 2, natural log, x squared plus 1. I want to write the derivative down for you. We'll look at the picture momentarily. That's 1 minus 2. The derivative of log is going to be 1 over its argument times the derivative of the inside of that, which would be 2x. Write that down for you. That's going to be, let's see, 1 minus 4x over x squared plus 1. Let me just stop for a moment and check myself and see how I did there. I got x squared plus 1 on the bottom. Yeah, minus 4x. I'm going to get into one rational expression, which is x squared plus 1. And then you get x squared minus 4x plus 1. All right? And that's the first derivative. All right? So someone says, why'd you do that? I did that because I want to look at the transition points. And before I go forward on this, I want to point out the domain of this thing is all the real numbers. I'm not worried about that. But what I'm worried about now is, where does this derivative take on a 0? All right, so I'm going to put that down for you, and then we'll look at the picture. If you want, you can look at the picture first and realize, well, maybe I should do that. Looking over here, I'm expecting, it's quadratic in form, by the way. I'm expecting to see those 2 points there. Let's go through that and write that down for you. All right, so I got to do x squared minus 4x plus 1 equals 0. Well, x equals quadratic formula, 2, 4, plus or minus. Let's see, the b squared, which is 16, minus 4ac, minus 4. X equals 4 plus or minus the root of 12 over 2. This is starting to shape up, isn't it? 4 plus or minus 2 root 3 over 2. So x equals 2 plus or minus root 3. Let's put them down for you, and we'll check the key in a moment. So I'll put this point over here. This would be 2 plus root 3, f of 2 plus root 3. This is a local min. Again, this thing goes up like this and down like this forever. This is going to be my local max. And that's going to occur at 2 minus root of 3, f of 2 minus root of 3. All right, let's just look at the key and make sure I'm doing okay with this. And what I mean by that, I did get this part, right? The local minimum, local maximum 2 minus root 3, I did get that part. The local minimum 2 plus root 3, I got that over there, all right? So that's good. Let's do the second derivative now. Right? It's far more difficult, right? Because I got to do the quotient rule. And let's put that down. So second derivative. Well, x squared plus 1 squared. We're differentiating this, by the way. X squared plus 1 times the root of the top, which would be 2x minus 4, minus the top, times the derivative of the bottom, which is 2x. All right, I got to simplify it. It's problematic. I mean, it's algebra, and algebra is very prone to error. I have an answer key though, and I'm trying to go towards that key, by the way. And let me just look at the top, and if I did that, let's multiply it out. So I'm going to do a little side work here. I'm going to erase it after I do it though. So it's going to be 2x cubed plus 2x minus 4x squared minus 4 minus 2x cubed plus 8x squared, and then minus 2x. Well, the cubes disappear. I'm glad for that, because I don't want to do it a cubic. And then what do you get? 4x squared. Then you're going to get no x's. They disappear. And then minus 4. All right, I'm going to keep plowing through this thing over here. We'll check the key momentarily. I'm going to say 4, and it's going to be x plus 1, x minus 1. Relatively simple factorization problem. Simple or not, I wanted to get it right. And what I mean by that, it's listed in your k as this. And that's good news, by the way. So then the question becomes is, what does this give me information about the concavity of it? So looking at it, I'm going to say there's 2 points where the concavity is changing. And it's at plus or minus 1. Right here. And let's see, right over, I said plus or minus 1, right? Yeah, well, I see it at 1. I see it going like this. But they also say 1 occurs at, which is really hard to detect, by the way, I'll be honest with you, looking at it. But this is concave down, and then what happens here, although it's really hard to detect, this thing's going to be concave up, all right? I'm kind of exaggerating it there. So I'm saying there's 2 points of inflection, right, at plus or minus 1. Really tough to see from the graph, by the way. But again, my analysis led to that, all right? So at plus or minus 1 are where the points of inflection are. Thank you.